Welcome to AI in 8 minutes or less, your daily AI update. Today, we're taking a look at the future of AI through the eyes of someone who's building it, Demis Hassabis, the CEO of Google DeepMind. He has this vision that's, well, it's both absolutely incredible and, you'll see, pretty darn scary.
Just let that sink in for a second. The person leading one of the world's top AI labs is saying there might be no limit. We are building something with a potentially infinite horizon, a tool that could literally reshape everything we know. So, what on earth does that future look like?
He basically sees this whole thing as a huge balancing act. On one side, you've got this incredible promise to speed up human progress like never before. And on the other, you've got the risk of creating something we can't control. So let's dive into both sides of that coin, starting with the really amazing stuff.
Okay, so the biggest promise, at least according to Hassabis, isn't about, just getting a better chatbot. It's about changing the fundamental speed of science itself.
His go-to example is drug discovery. Think about it. For hundreds of years, finding new medicines has been this slow, painful process of trial and error in a wet lab. Hassabis says, what if we could move that entire search from the lab to the computer? We could run millions of experiments virtually in just a fraction of the time.
And this is how it works. It's this amazing self-improving loop. The AI designs a possible drug. Then, it doesn't just test it against the one protein you want to target, it tests it against all 20,000 proteins in the human body to check for toxic side effects, like instantly. Then, based on those results, it tweaks the drug design to make it better and safer, and runs the whole loop again, and again, and again, getting better each time.
And get this, it's not just for medicine. You can apply this exact same idea to finding new materials for super efficient batteries, designing smarter energy grids, or, and this is a bit wild, having the AI write better AI code to improve itself. It's basically a platform for hitting fast forward on all the hard sciences. But to get to that future, we have to deal with some very real dangers.
All right, so now we have to talk about the flip side of the coin, because with this kind of power comes, massive responsibility. And Hassabis is super clear about the catastrophic risks we need to solve.
So what is he really worried about? Well, he boils down his biggest concerns into two main categories. These are the two giant hurdles we have to get over to unlock all that good stuff we were just talking about. He splits the problem in two. First, you've got humans with bad intentions using the tech. And second, you've got the AI itself becoming the problem. Let's break down exactly what he means.
Risk number one is pretty straightforward. Bad guys, whether it's individuals, groups, or even nations. Hassabis points out that these are dual-purpose technologies. The same AI that can design a life-saving drug could, in the wrong hands, be flipped around to design a chemical weapon, or maybe a substance more addictive than anything humans have ever created. The second risk, well, this is the one that sounds like it's straight out of science fiction, the AI itself going rogue. As we start building these AI agents that can act on their own to complete goals, how do we make absolutely sure they stay on mission? He says this is a huge problem we need to solve in the next 2, 3, 4 years. It's a massive technical challenge. How do you build guardrails that a system smarter than you can't just talk its way around?
And all of this, the promise, the peril, it all brings us to one final, ultimate question. This is the big one that's going to determine how far any of this can actually go.
See, to figure out what the true ceiling for artificial intelligence is, we first have to answer a really basic question about our own intelligence. What exactly is it? What's going on in our heads?
And it really comes down to this debate. You've got two main camps. Is the brain just a really, really complicated biological computer? That's view one, the one supported by pioneers like Alan Turing and largely by Demis Hassabis. Or is there something else going on? Something weird, like quantum effects, which some physicists like Roger Penrose think might be the secret sauce to consciousness.
Hassabis is pretty direct about where he stands on this. He says, look, we're open-minded, but so far all the evidence from neuroscience seems to show the brain works like a classical computer. We just haven't found any of that special quantum stuff.
And this is why that matters so much. Because if the brain is, in fact, computable, that means everything our minds can do, creativity, reasoning, dreaming, planning, it can all, in theory, be replicated by a machine. There's no magic ingredient. There would be no physical barrier stopping an AI from matching and maybe one day far surpassing us.
So, after all that, the incredible dreams and the profound risks, the final question really isn't about the machine. It's about you. Seriously, think about it. What's happening in your head right now as you listen to this?
Is it just a fantastically complex series of calculations? Or do you feel like there's something more to it? Because how you answer that really shapes how you should be thinking about the future of AI.
If you enjoyed this, subscribe to AI in 8 minutes and never miss what matters.